Right, salam sejahtera and assalamualaikum, doctor. So we are from group 10. So today we would like to present our fluid mechanics project. So first of all, my name is Nicholas Majid, and here's our group member. First, myself, Nicholas Majid. Next, Malai Ahmad bin Malai Johan. The third one, Anish Tazliana binti Muhammad Zainur Rahman. And lastly, Nur Ain Farhana binti Abdullah. So this is our team member. Thank you. So I will start with introduction. So in this presentation analysis, Malaysian flooding issue by examining the factor that contribute to flooding and exploring practical engineering solution to reduce its impact. And next, the primary objective of this presentation is to develop and demonstrate essential skills such as leadership, critical thinking, problem solving, teamwork, and effective communication for this study lah in hydrostatic force topic. Yeah.
This project focuses on the issue of flooding, which has become more frequent in Malaysia in recent years. Floods are caused by factors such as rapid urban development, climate change, and high tides in coastal areas. These disasters can threaten public safety and cause serious damage to property, infrastructure, and the environment. Through this project, we also study the hydrostatic forces acting on some structures. This helps us better understand how water pressure affects engineering structures during flood. In addition, the project improved our analytical thinking, teamwork, communication, and technical reporting skills. Overall, this study increases our awareness of flood challenges and the importance of effective engineering solutions.
Okay, hello, good evening. This is our presentation. Okay, now moving on, there are three things that we need to understand before we can answer the questions. Firstly, hydrostatic force, hydrostatic law, and how these two concepts will be applied to solve problems. Firstly, what is hydrostatic force? Hydrostatic force is pressure exerted by a fluid at rest on the surfaces of objects submerged within it. So easy to say, pressure acting upon something that's underwater, under fluid, but in this case, underwater. Next, hydrostatic law. Simply put, it is a law which describes how pressure varies with depth in a fluid at rest. Senang cerita, the deeper you are, the more the pressure. That's it. And then the practical application. Okay, so before we can continue into our topic, there are three fundamental things that we need to understand. First, hydrostatic forces. Hydrostatic forces refer to the pressure exerted onto a submerged surface by fluids. So in our case, the submerged surface would be the gate. The fluid would be seawater and fresh water. Next would be hydrostatic law. Hydrostatic law states that pressure varies with depth in a fluid. So easy to say, the deeper you go, the higher the pressure. Next, practical applications or how knowing these two concepts will help us in solving problems. These two concepts helps us by providing the location and magnitude of water pressure force acting on water control structures such as dams, levees, and gates, which is very important to make sure they are have adequate strength to handle hydrostatic force exerted onto them by the fluid.
Assalamualaikum. My name is Nur Ain Farhana and I will explain about hydrostatic force formula. The main formula for hydrostatic force formula is P equals to F over A or P equals to rho GH. where F is for hydrostatic force, P is for pressure at centroid on submerged surface, A is the area of submerged surface, rho is density of fluid, G is gravitational acceleration, which is 9.81 meter over s negative 2. H is vertical height, the center of gravity of the wet surface to fluid surface. From this formula, we can understand that the hydrostatic force is increased when the depth on the surface is increased. This means that the deeper the object is submerged, the greater the pressure and force acting on it. The second formula is Hp equals to Ic sin square theta over AHc plus Hc. This formula is used to determine the center of pressure, which is the exact point where the hydrostatic force acts on the surface, where Hp is vertical height of hydrostatic pressure force from the fluid surface, theta is inclined angle of the plane surface with respect to the horizontal fluid surface, and Ic is for the moment of inertia about the horizontal line through the center of gravity of the submerged surface. In conclusion, these two formulas are important because they help engineers calculate the magnitude of hydrostatic force and determine where the force acts. These two information is essential when designing hydraulic structure such as dams, gates, and water tanks to ensure they are safe and stable. Next question is rectangle shaped gate. First of all, we need to calculate the area of the gate. We got 6.25 meters square. And next, we need to calculate the HC. We got seawater is 3.75 meter and the freshwater is 1.75 meter. Next, we need to calculate the force acting on the gate. For seawater, we got 235.61 kilonewton, and for freshwater, we got 107.29 kilonewton. Next, we need to determine the center of the pressure. We got seawater 3.889 meter, and for freshwater, we got 2.048 meter. Then, we calculate the distance from the hinge to the line of action of each force. The seawater force acts 1.389 meter below the hinge, and the freshwater force acts 1.548 meter below the hinge. Finally, we calculate the moment by multiplying force with its distance. The seawater moment is 327.35 kilonewton meter, and the freshwater moment is 166.10 kilonewton meter. Since the seawater moment is larger, the net moment pushes the gate towards the freshwater side, which means the gate will open to the right. Next, we analyze the inclined gate for rectangle shaped gate at an angle for 60 degrees. First, we calculate the vertical height of the gate. Using trigonometry, 2.5 sin 60 degrees, we obtain 2.165 meter. After simplifying it, we obtain a quadratic equation. We use quadratic formula for find value of the x. We got two values of x. The first one is 2.9418 meters, and the second one is the negative one. We can check the negative one because a negative water depth is not physically possible. Finally, the freshwater level is h equals to x plus 2.1651 meter, and we got 5.107 meter, approximately 5.11 meter. Therefore, when the freshwater level reaches approximately 5.11 meter, the moments on both sides are balanced. At this water level, the gate is just about to open.
Okay, right now I will present about question 1. Okay, first of all, question 1, the question is asking to determine the hydrostatic force and their location developed at the gate. Next, if the height of the gate is 2.5 meter, neglect the gate weight, what will happen to the gate? Okay, here's the solution here. First of all, the question already give us this information here. We have AC, we have G, and for HT, so HT is the depth of the centroid. So to find the HC, we need to minus height 5 minus 2.5 over 2. Sorry, 3. So we get 4.617 meter. All right, next, AR. So AR, yeah, A. So basically AR is a area of the gate for the triangle shape. So we just use the formula and insert all the information given, and then we got 3.125 meters square for the area. Okay, next. Um, sorry. Next for F. Okay, so F is stand for hydrostatic force. So to find the hydrostatic force, we need to use this formula, which is rho GHA. So simple, we just put in all the value, rho, G, H, and A, since we already have all the information here. Just plug in and use our calculator to calculate, and we got 130.94 kilonewton. Okay, next, IC. So IC is stand for second moment of area. So here's the formula here. So simple, we just plug in all the value and to the formula, and then we got 1.085 meter to the power 4 for the second moment of area. Okay, next HP. So HP stand for center of pressure. So here's the formula. We just use the formula given and plug in all the value for the equation, and then we got 4.25 for HP. And then next, location of F1 from HA. So here's what it means. We need to find the location for F1. Where's the force acting on the gate? So also simple, we just 4.25, which is the value of HP minus 2.5. We get 1.75 meters. So that's the location for F1. And then the last one is moment. Moment acting on the gate. So simple also, we just use the formula of force times the direction. Yeah, so we use for the direction, we use location of F1. So force times 1.75, we got 229.15 kilonewton meter. So that's the moment acting on the gate for seawater side. All right, next part,